So the first problem we're going to look at today is a square root problem. And it's the square root of 6x minus 2 equals x plus 1. Now, we want to isolate the x by itself, just like we always do in equations. But first thing I want to do is I want to square both sides of this equation just to get rid of the square root. So here it goes with the square root of 6x minus 2 squared equals x plus 1 squared. Of course, if you square square root, what happens? Cancels out, right? So I've got 6x minus 2, and then this one, remember, you square x plus 1, it's not x squared plus 1. It's the same thing as multiplying x plus 1 times x plus 1. So we said earlier, remember, it's the first term squared, then it's 2 times the first times the second. So 2x, and then plus 1. And now it's just a standard equation. Standard quadratic equation. Keeping the x squared term positive, I'm going to keep the x squared on the right. 2x, you take away 6x, you get what? Negative 4x. And then 1, and you take away negative 2, becomes 1 plus 2, which is 3. All right. So at this point right here, we get x minus 3 and x minus 1 as our factors. So from that, x equals 3 and x equals 1. Now, there's one other thing we need to do here. Because this is a square root problem, we need to check our answer. Anytime you run into a square root problem, you have to, or a problem where you either square every side or take square roots of every side or whatever, you need to make sure that in doing so, you don't come up with a solution that does not work. So going back to the original problem, plugging in 3. 6 times 3 is what? 18. And then minus 2. And the square root of 16 is 4. And is that equal to 3 plus 1? Yes. Yeah, those are equal. So 3 does work. All right, now, what about here? You got your 6x, which is 6 times 1 minus 2. And checking that with 1 plus 1. That's the square root of 4. And what do we know about the square root of 4? It's 2. And 2 is equal to 2. So both of these solutions work here. Next we have x minus 1 to the 2/5 power and setting that equal to 4. Now, this one isn't just a square root, although the fact that you have a fraction implies that you're dealing with a root. So it's really the 5th root of x squared. Well, the way we undo a root is we raise both sides to the reciprocal. So the reciprocal of 2/5 would be what? 5/2, yeah. So I'm going to raise both sides here to the 5/2. Okay, well, now it's typically better to work with the denominator first, because if you work with the denominator, you're going to be dealing with smaller numbers. So again, A 2 in the denominator means the square root. So I want to take the square root of 4. What's the square root of 4? 2. And then I'm going to take 2 and raise it to the 5th power. Anyone know what that is right off the top of your head? 32, very good. And that wasn't even a combining like terms problem. You're an expert on a lot of things. So we end up with 33 as the solution here. So let's, again, we started doing exponential things with the problem, so let's just check it to see if it works. 33 minus 1 to the 2/5 power. That's 32 to the 2/5 power. Again, if 2 to the 5th is 32, then the 5th root of 32 would be 2. And 2 squared is 4. And that's what it should have been.
How did you get to 32 again? I know you did
This 32?
yes, like
Okay.
how did you decide it?
Okay, question is how did this 32 come about?
Yeah.
This 32 came about by this, and I'm gonna rewrite this as the square root of 4, because that's what the 2 in the denominator refers to, square root of 4 to the 5th power. And because the square root of 4 is 2, we get 2 to the 5th power, which is that 32.
Okay.
Did that answer what you were asking?
Mhm.
Okay. Any other question here? All right, those of you who have phones need to go ahead and put them away. Next we have x minus 2 squared plus 2 times x minus 2 minus 15 equals 0. All right, now, one thing that you could do here to solve this problem out, and I'm going to work this problem 2 different ways. One thing you could do to work this problem out is to go in and do all the arithmetic in here that you see. So I have x minus 2 being squared, so that's x squared minus 4x plus 4. And then right here I have plus 2x minus 4 minus 15 equals 0. All right, we have some stuff that cleans up here, right? What cancels out up here?
The 4.
The 4's cancel out, so I've got x squared. Then negative 4x and 2x is negative 2x minus 15 equals 0. Okay. And then this would become two things that multiply to give us 15, but add to give us negative 2. And 3 and what?
Negative 5.
Negative 5, yeah. So x minus 5 times x plus 3. And you can double check by distributing x squared minus 5x and plus 3x is negative 2x. And you got your negative 15 there. So x equals 5 and x equals negative 3, right? And that's definitely one way to solve the problem. There is another way to solve this problem. And that's not by looking at someone else's paper. All right, that's supposed to be a joke. May have hit a little close to home for some of you. All right, now, I'm going to do something called a U substitution. And I'm going to substitute U in for x minus 2. So I'm going to let U equal x minus 2. So my new problem is U squared plus 2U minus 15 equals 0, right? Do y'all see what I did there? So this saves me having to square my binomial and so forth. And this would be U plus 5 times U minus 3, right? So I get U equals negative 5 and U equals 3. Now, you're thinking, well, right here we said 5 and negative 3 were our answers. Now we're getting negative 5 and positive 3 as our answers. But we're not done yet, because we didn't say that we weren't solving for U, we were solving for x. So where I have this U, I'm going to say, well, let's let that be x minus 2. So x minus 2 equals negative 5, and x minus 2 equals 3. So if I add 2 here, I get negative 3. And if I add 2 here, I get 5. So I do end up getting the same solutions, negative 3 and 5, either way. So again, this is a case, and the trick is to recognize that it's in that form where these two values could be turned into a quadratic. But if you don't see that, and you do that solving, you get the answer fairly quickly. Here, I don't know if it's any quicker or not, but it's just two different ways to go about solving out the same problem. So I'm going to give y'all just a few minutes. That was section 1.6. So give y'all a few minutes to work on that. I've got to set up the video for the next part of the lesson, and then we'll go from there.